This video talks about the bridge rectifier. It's another full wave rectifier configuration. We'll start off with the primary side, then we have the secondary side. Now I'm going to draw the arrangement of diodes. I'm drawing all the diodes pointing left to right. And I make a diamond shape like so. So my connection points are the four corners here where the diodes intersect. I'm going to connect the secondary to the top like so. I'm going to connect ground to this side, and from this side a resistor to ground, or load resistor. And again, I could have drawn the load resistor in the center like so, and that would be the exact same thing, but drawing it to the side makes it easier for when I want to draw the filter capacitor beside it. So I'll stick with the beside arrangement there. So again, we have our primary voltage coming in. On the secondary side, we have a positive cycle and a negative cycle, so we're color coding for these. Notice that this transformer does not have a center tap, so I'm not using a center tap of this transformer because it's not there and we don't need it. So for the positive cycle, the polarity is this, and again we want to remember that +1 is bigger than 0, but 0 is more positive than -1. So in our arrangement, we have plus, ground, and minus. Ground is more positive than the negative side. So let's keep that in mind, and we're going to decide which of these diodes is going to be on or off. So we have a negative side here, a positive side here, and a ground side here. So this diode is going to be off. This diode is going to be on. I've got negative coming to here. So this diode is going to be off. And remember that ground is more positive than negative, so this is actually biased to be on. So the key thing to notice here is that the diodes are turning on in pairs. These two are on, these two are off. So the on will allow current flow, the off is acting like an open circuit. Okay, so let me just erase the yellow lines here. And actually, you know what, just to remind us that current is not going to flow through them, I'm going to keep the yellow X's on those two diodes for now. So let's see the current flow. The current is going to flow from here through this diode, through the load resistor in this direction. So I'm going to have an output like so. Then it's going to come back through the ground, through this diode, and back like so. Okay, so that's for the positive cycle. Now for the negative cycle, I'm going to erase these yellow X's and we'll do the polarities again. So the negative cycle is going to have a polarity like so, which means the polarities on all these diodes reverse. So this diode is going to be on, because remember ground is more positive than negative. This diode is going to be on, and these two diodes are going to be off because they'll be reversed biased like so. Off in that case. So that's starting to look confusing. Let's just remind ourselves that these two are off in the negative cycle case, and the current flow will be like this. It's going to start here It's going to go through this diode, through the load resistor in the same direction, which means our voltage will be like this. It's going to come back through the ground and around like so. Okay, so I encourage you to draw this circuit on paper. Draw it twice and do one for the positive cycle showing the path, another for the negative cycle showing the path, so you can really see what's going on there. Now, regardless of which cycle we look at, notice that it's the full V secondary that we've got available to us. So this is the V secondary peak. So our VL peak, our peak load voltage, is going to be our secondary peak minus, notice for each case we're passing through two diodes, so minus the drop of two diodes, which is 0.7 times 2, so 1.4 volts, and it's the same for the positive or negative case. And of course, as the cycle repeats, the output keeps going there. And one thing to notice, if we're looking at these outputs, so for the full wave rectified circuit, if the input is an AC waveform like this, the output is a rectified voltage like this. And so the frequency of this output voltage there is actually 1 period. So the frequency of this output voltage is actually equal to 2 times the frequency of the input voltage. Okay, so because now the positive and negative cycles are actually the same, so our frequency has effectively doubled and our period has been cut in half. So that is something to keep in mind. It's going to come in very handy when we troubleshoot the circuits with filter capacitors on, where we can't see this actual waveform anymore. So just something to keep in mind there.